Welcome back, everyone. Today we're starting on consumer theory, and I mentioned this in class last week, but consumer theory is one of my favorite topics in economics. And the reason is we've been building up this concept of demand as built on tastes and preferences. But today we really get to start to unpack what that means. We started this semester defining economics as the science of human behavior, which studies our relationship between ends and scarce means. And we're really going to rely on that definition today when we study consumer behavior, describing how consumers are going to allocate their incomes among different goods and services to maximize their well-being. In other words, we're concerned about well-being as this ultimate end, and we have so many different ways we can achieve well-being, but we only have scarce income to achieve it. To get to that point, it's helpful to divide consumer behavior into three different steps: preferences, budget, and choice. So what do we as consumers do? We make choices based not only on our tastes and preferences, but also what's available to us because of the price of goods and how much money we have. However, to first understand the role of these preferences in consumer choice, it's helpful to take a short history lesson. When economics as a field was first being developed, it was closely intertwined with the other social sciences and moral philosophy. So here we have two, I'll say economists, but you might think of them as moral philosophers in Jeremy Bentham and John Stuart Mill. And we describe these two as utilitarians. And what they believed is that we could put a numerical measurement on our preferences. Bentham believed that pleasure and pain were put here by nature to guide us. So if an action gives you 5 units of pleasure and only costs you 1 unit of pain, compared to an alternative action that gives you 2 units of pleasure and costs you 2 units of pain, you should take that first one because the net benefit is, higher. The fact that we can measure pleasure and pain, and more broadly, the fact that we can measure preferences, would imply that there's a role for society here, because we can outline a goal to get the greatest good for the greatest number of people at the least cost. Note that this is not a laissez-faire view. It implies an active role for some sort of government. It also implies the need for an educational system to teach people how to achieve their best good. This idea that we can put a numerical measurement on our preferences is what your book will refer to as cardinal utility. And again, note that we're talking about utility theory here, and these are utilitarian philosophers. What cardinal utility suggests is that we can describe our choices and ultimately make our choices by recognizing how much better one is than the other. Note that that's incredibly quantitative. The other fun thing about the early utilitarians, Jeremy Bentham in particular, is he had his body donated to science. So a quick trigger warning: if you don't want to see something gruesome, fast forward over this next slide. But that's what his decapitated head looks like. And indeed, his entire body is preserved and on display at the University College of London. So the utilitarians have this idea of cardinal utility where we can just compare our utility from one basket to our utility from the other basket, and if one is greater than the other, that should be our resulting choice. But in the early 1900s, there was this push to make economics more scientific, to replace the hedonism of the early utilitarians with choice sets. So people can still have a preference ordering, but we can't measure it in the same sense. Rather than knowing how much better one choice is than another, we can just observe the rank ordering of choices. So I don't know that 5 is 2 more than 3, but I do know that 5 is more than 3. And your book would refer to this as an ordinal utility function. The idea that our choices generate ranks from most to least preferred. This actually coincides well with the development of a bunch of new forms of mathematics, where the field moved away from constructs like calculus and more towards constructs of topology and set theory and axiomatic foundations. To that end, at the tail end of the ordinal revolution, economists like Paul Samuelson took that concept of ranked utility even further. Paul Samuelson was really influenced by these outside critiques of economics, as well as the behavioralists like Skinner, and so he believed that people were inscrutable. We can't know what's going on in their heads. We can't know that you like candy more than Brussels sprouts. But what we can do is observe your choices. And in observing your choices, we might see that when candy and Brussels sprouts are the same price, you're picking candy over Brussels sprouts. This is what's known as the revealed preference approach, and speaks to this push to make economics empirical and operational. Now, throughout our chapter on consumer choice, we'll be talking about all 3 of these approaches: the cardinal approach, the ordinal approach, and the revealed preference approach. But what's particularly interesting is with the development of new technologies like fMRI scanners, we can start to measure the amount of dopamine, the amount of serotonin active in someone's brain, taking us back to that original idea that we can measure preferences and we can measure them to a numerical approximation. In other words, I can put you in a scanner and see that candy actually gives you 5 units of happiness or 5 units of dopamine, whereas Brussels sprouts might only give you 2 or 3. Remember that this is all a way of saying that what we're trying to do in consumer theory is compare and describe how consumers are allocating their income, their scarce resources, among different goods and services in order to maximize their well-being. So in understanding how preferences are constructed, we can understand these choices they'll eventually make. In other words, what we're asking is whether consumers prefer one thing to another. And those things that we're asking about are market baskets. Now, you may remember the term market basket from our macro discussion of CPI, but all a market basket is a list of quantities of one or more goods or services. So in this table right here, we're comparing several different market baskets, and these baskets are comprised of food and clothing. But remember, it can be anything. It can be education and exercise. It can be more than 2 things like Snickers, M&M, and Milky Way. Oftentimes what we'll do in econ is just compare one thing to another unit of everything else. And we'll call that a numeraire good. Here we're comparing food and clothing, and we have a bunch of different baskets. For example, in this first basket, we have 20 units of food and 30 units of clothing. Note that they don't all have to sum up to the same amount. Here we have 10 and 50, and so on and so forth. And it's our goal as economists to describe what the consumers like more, what the consumers prefer. To do so, we might find it prudent, we might find it useful to make some basic assumptions about these preferences, about who likes what more than the other. The first assumption we're going to make is completeness. And what completeness says is that you can make a choice. So if I were to ask you whether you would rather have an apple or a banana, you are able to make that choice. I would prefer the apple, or I would prefer the banana. Note that indifference can exist in a situation of completeness. There's nothing wrong with saying I would prefer the apple just as much as I would prefer the banana. What makes preference orderings incomplete is if you are unable to choose. And the classic example here is between the lives of two of your children, like in Sophie's Choice. It's important to note that preferences does not take cost into account. We'll get to that later when we discuss budget sets. But though I might like apples more than bananas, I might buy bananas because they're cheaper. The second, well-behaved preference assumption we're going to make is transitivity. And what transitivity means is that preference ordering transfers. So if you like apples more than bananas, and you like oranges more than apples, then you also like oranges more than bananas. In other words, transitivity is an assumption about consistency. Note that there's nothing that says these have to be transitive across state spaces. So I prefer to have an umbrella when it's raining out. I prefer to have sunglasses when it's sunny out. There's nothing intransitive about my preferences switching when the state of the world has switched. It's also worthwhile to note here that a lot has been said about the economic approach to rationality. But as you progress in your careers as economists, you'll learn that in terms of preferences, all we need to be rational, and I'm saying that with air quotes, is complete and transitive preferences. So the ability to make a choice and consistency across those choices. The final assumption we're going to make about preferences is that more is better than less. Goods are assumed to be desirable. And you'll note, rather than the completeness and transitivity assumptions, this one is really made more for convenience. For instance, we can name lots of situations where more is not better than less. For instance, pollution. In those situations, though, we can always flip the bad to the good. So if more pollution is worse, then more pollution abatement is better. What about something else where we might be sated? So I have 2 cats. If I started adding more and more cats, say 15 more, I would argue that is not better than less. So on your own, think about where these assumptions might hold and more to the point, might not hold. Because if we think about how we can break these assumptions, it's really useful in understanding how they work. Tying together these minimal assumptions we have about preferences with the market baskets between food and clothing that we saw earlier, we can start to make some basic comparisons. If we have complete preferences, we can compare all these baskets. If we have more being better than less, then A is better than G, and E is better than A. And if we have transitive preferences, the fact that E is better than A also means that E is better than G. However, we can't compare A to B, D, or H without additional information. And that additional information graphically is going to look like an indifference curve, which is a line where every point on that line represents the same level of satisfaction, or what we hinted at earlier, we're going to call utility. So let's draw what one indifference curve might look like. And we'll punt for now on where we got the shape of this curve and focus more on the implications of such a curve. Remember, an indifference curve represents all possible market baskets with the same level of satisfaction. What that means is that on this indifference curve, you are indifferent between market basket A, market basket D, and market basket B. But you prefer any of these baskets to market basket H or G. Everything above the indifference curve is preferred to this level of preference. We'll call it U1. And everything below the indifference curve is less preferred than this level of preference we called U1. By putting a bunch of different levels of preference, here we have U1, U2, and U3, on the same graph, we have an indifference map. And using those same rules we laid out in the last slide, we can see that A is preferred to B, and B is preferred to D. By our transitivity rule, that also means A is preferred to D. It's this sense of transitivity that implies that indifference curves cannot intersect. To see why, let's consider this situation in reverse. Here we have B on the same indifference map as A, and B greater than this level U2 where D sits. But we also have A on this same indifference map as D. So we have B equal to A, B not equal to D, and A equal to D, which mathematically doesn't make any sense. From our indifference curve, we can get at our construct known as marginal rate of substitution, which is asking how much of one good do we have to give up such that an additional unit of the other good, in this case food, leaves us at the same level of satisfaction. How much clothing do we have to give up such that an additional unit of food leaves us just as satisfied? Mathematically, this is the slope of the indifference curve. And you'll note that because our indifference curve, at least in this case, isn't a straight line, the marginal rate of substitution will change depending on where we are on the indifference curve, going from 6 to 1 at the very bottom. Why is that the case? Because people tend to prefer mixes to extremes. And when that's true, we have a diminishing marginal rate of substitution. The maximum amount of a good that a consumer is willing to give up in order to obtain an additional unit of the other good gets smaller and smaller as we move down the curve. In the case of convexity, in the case where people prefer mixes to extremes. What this looks like is with convex preferences, we'll have indifference curves bowed toward the origin. Now it's important to note that implicit here is that people have different preferences. What we say in econ is heterogeneity of preferences. And this is really profound, not only because people can like different things, but it was something that was hard for me as a student to wrap my head around. I mean, certainly, shouldn't everyone have the same preferences that Sweetbriar is better than Holland's, or that my classes are better than Dr. Hardy's? Well, first off, no, some of you might unfortunately prefer Dr. Hardy's teaching style, but also it's not just the absolute preference, but the relative weight we put on each preference. So some of you might really be concerned with who your econ professor is, and some of you, though you might have a preference or you might be indifferent, might want to just get econ out of the way so you can get back to the riding stables. Heterogeneity of preferences implies not only different preference orderings, but also different weights we place on our preferences, different marginal rates of substitution. The other reason we say people tend to prefer mixes to extremes without saying it's true in absolute is because of the degree of complementarity or substitutability between goods. And when studying demand theory, we talked about the price of related goods as something that might shift demand. But now we get to explore what that relatability actually means. And the degree to which something is complementary or substitutable depends on that marginal rate of substitution. In the case of perfect substitutes, where you don't care between the split between one good and the other, the marginal rate of substitution is always going to be constant. Now, this doesn't mean it's always going to be 1. For instance, the marginal rate of substitution between Reese's Pieces and a Reese's Cup might always be 5-1. But if that rate of substitution is constant, they are perfect substitutes for one another. In terms of goods that are perfect complements, the marginal rate of substitution is either 0 or infinite. And what that means in terms of the indifference curve, which we'll see on the next slide, is it will join at a right angle. Remember, we tend to think of left shoe and right shoe as perfect complements. If I have 2 right shoes, having a third left shoe doesn't do me much good. What does this look like in terms of the indifference map? Well, in the case of perfect substitutes, we're going to see straight lines. So in this example, Bob views apple juice and orange juice as perfect substitutes. Bob only cares about pure glasses of juice. And certainly, Bob prefers to have 4 glasses of juice to 3 glasses of juice. More is better than less. But whether that looks like 4 glasses of apple juice, or 4 glasses of orange juice, or 3 glasses of orange juice and 1 glass of apple juice, Bob is indifferent between those. In this next panel, we have perfect complements. And again, you'll see the marginal rate of substitution is either infinite, so I'll draw a little infinity sign here, or 0. And again, we have that left shoe and right shoe. In this case, Jane has 2 feet and an additional left shoe when she only has 1 right shoe gives her no satisfaction. An additional right shoe when she only has 1 left shoe gives her no additional satisfaction. We'll close our discussion of preferences with this thing we've been hinting at all lecture, this construct of utility, which is just a mathematical representation of your preferences. Now here, we're giving utility a numerical score, which would imply that first type of utility. We talked about cardinal utility. We can say that U3 is 50 utiles more than U2, and U2 is 25 utiles more than U1. But we don't have to say that. We can just say U3 is greater than U2 and U2 is greater than U1, implying some sort of ordinal utility. So I'm going to erase that. Mathematically, if we have some sort of formula that can take our indifference curves and put them in functional form, we call that a utility function. It's a formula that assigns a level of utility to our market baskets. And the way it works is we'll have some input. Again, we'll stick with clothing and food. And from this input, we'll know that 10 units of clothing and 2.5 units of food give us the same utility, in this case 25, as 5 units of clothing and 5 units of food. So these different inputs into our utility function, food and clothing, are going to give us the same output. In this case, you'll see here that our utility of food and clothing is given by amount of food times amount of clothing. So 10 times 2.5 gives us 25 here, and 5 times 5 also gives us 25 here. With that, we'll wrap it up for this first half of Chapter 3, and we'll come back next time to start to think about how choices are made now that we have preferences clearly defined.